Good evening, everyone. This is June 2016, Unit 5 of IAL Physics. In the first question, a mass is hung from a spring and set into vertical oscillation. The resulting force of an oscillating mass always acts. So we know force is directly proportional to acceleration, and in a simple harmonic motion, or acceleration is directly proportional to displacement, which is always directed towards the equilibrium position. So B is the right answer, because we can relate acceleration with displacement, or we can relate the force with displacement as well. Radiation beam therapy can be used to kill cancerous cell in the body. One treatment for brain tumor detect many narrow beam of radiation from different direction into a cancerous cell. What would be the most suitable radiation for this? Gamma is the most suitable because it is highly penetrating, so can pass through easily. Americium is a radioisotope that decay by emitting alpha particle. The difference in the mass is MeV per c square between americium and the product is delta M. The energy release in this decay can be given by, so we have the formula E is equals to mc square, or mass defect. So we'll know how much energy. So mass is delta M, and that is in mega electron volt per c square, and this is multiplied by c square, so c square will cancel with c square, so we are left with delta M MeV. That will be the energy released when this mass will change into energy. For question 4, standard candle cannot be used to determine the distance. It can be used for nearby star, because the main idea of standard candle, we consider that they have the known luminosity. For distant stars also it can be used, nearby galaxy can be used, but not for distant galaxy because we are not sure of their luminosity. So D is the right answer. A suspension bridge is being driven into oscillation as a car moves across it. The energy of oscillation of the bridge is doubled. The amplitude of oscillation increases by a factor. So the relation energy is proportional to amplitude square. So, or displacement square. So if energy is double, because it vary with the square, so this amplitude should increase by under root 2, because under root 2 square will be, the energy will be 2 times. So C is the right answer. A mixture of hydrogen and nitrogen is used to inflate a balloon. On average, the nitrogen molecule in the mixture, so they're used to inflate a balloon because if they are moving with the same, they will have the same temperature. So the momentum of the nitrogen molecule will be higher because momentum is a product of mass and velocity. So if temperature is same, both gas particle will move with the same speed, but because of greater mass, the nitrogen molecule will have a greater momentum. Deuterium is an isotope of nucleus of deuterium, has a mass Md. It contains one proton of mass Mp and one neutron of mass Mn. Which of the following can be used to calculate the binding energy? So binding energy, the mass of the, because independently the particle will have more mass as compared to when they are inside the nucleus. So mass of proton minus the mass of neutron, mass of proton plus mass of neutron individual minus the mass of the nucleus, which is mg, that will give us the mass defect, and that should be multiplied by speed of light square to get the energy, using E is equals to mc square. So C is the right answer. When two protons are placed in a small distance apart, electric and gravitational field act on each proton. Which of the statement about this situation is not correct? The force act along the line joining the center, that's true. The electric force is greater than gravitational, that's right, because the value of the K is higher. The electric force may be attractive or repulsive, that's wrong, because these are two protons, it will always be repulsive. The gravitational force is always attractive, that's also a true statement. The property of young group of stars are compared with those of old group of stars. Both groups contain similar number of stars. In a young group, there will be more high mass main sequence star. Why? Because if we say low mass main sequence star, low mass main sequence star remain in main sequence for a longer period of a time. So the old group and the new group may have the same number of low mass main sequence star. But high mass main sequence star, because in the beginning, due to hydrogen fusion, we have more high mass star, but they shift instantly, not instantly with the passage of a time, but compared to other star, they switch to red giants or supergiants in a short interval as compared to other stars. So A is the right answer. Hertzsprung Russell diagram is given below. The luminosity and temperature. As a star burn hydrogen, they evolve. So from main sequence, they will move to red giant. So it will move from Q to R. So B is the right answer. So this was June 2016, Unit 5 of IEL Physics.